Hello, this is our Lab 4 with the alarm clock, and I will be talking about one of our modules, which is the counter module, which contributes to displaying on the 7th segment and counting the clock on its own. So for the inputs, we have the clock, and we have the set time switch, and we have some set seconds, set minutes, and set hours to set the time, which Luca will talk about later. And then we have three output registers. We have seconds, minutes, and hours. So for converting the 100 megahertz clock to count for 1 second, which we want, we used this block of code right here. So max count is 100 million minus 1. And when counter 100 gets to that point, it goes back to 0, but else it'll keep incrementing by 1 bit, which makes it a 1 second counter on our clock, which we later use to make our clock. And then in this block, we do all of the clock stuff. So if that switch is on, we set the time to whatever we want using the button, which I'll show later. And then we have if counter n, which is every second. The seconds will increment by 1 unless it is greater than 59. And then, no, less than 59, sorry. And then if it's greater than 59, seconds goes back to 0, and then minutes will increment. And then we repeat this procedure with minutes and hours. And then once it hits 24 hours, 59 minutes, and 59 seconds, it sets everything back to 0 and it resets.
Okay, so for the set time, we decided to do one hot encoding for seconds, minutes, and hours, just to decide which value we're going to save the number to. And for that, we have a case statement based on place. Place is a 3-bit input. It's just the 3 switches that we're using to control what we assign the values to. And in order to assign the value, we use the button on the FPGA and the debouncer in order to count up. And then the set time module also has another switch called OK switch, which is used to save the value to the variable. And then our decoder is where everything comes together. We call the counter, the module for the counter to display it on the 7th segment, set time and set alarm. And then to make the alarm ring, we turn on LED light when the alarm rings, and we just compare the values set for the alarm to the current time. And the ring mode also has to be on, otherwise it will not ring. And then in order to switch between 24-hour mode and 12-hour mode, we subtract 12 from the hours if the hours are greater than 12 and if the mode is set to 12-hour mode. And then we have an LED that turns on to tell us if it's PM or AM. It's on when it's PM.
This is our Lab4 clock running right now. It's set to about 3:16 p.m. And we have some switches to decide whether it's hours, seconds, or minutes. We have a switch to set the alarm. We have a switch to set the time. We have a switch to save the value after you set the time. And we have a switch for having the alarm play, so that's the LED. And we have a switch to switch it to 12-hour mode. And for the inputs, it's a button to choose like how many hours, seconds, and minutes you want the time to be.
So first we'll demonstrate switching between 12-hour mode and 24-hour mode. Right now it's in 24-hour mode. As you can see, it shows 15. If we flip the switch, it will show 3, and then if the LED turns on, that means it's PM, and it will be off when it's AM. So we can go back to that. And then if we want to set the time, for example, to 2:05 and 10 seconds AM, we can set, this is the switch to set the seconds. So I'm going to reset that and count to 10. And then save that value. Then for the minutes, we'll set that one, reset that, set it to 5. Save that value. then reset that, and then for the hours you can set it to 2. Save that value, and then you can set the clock. That sets it to 2:05:10, and then that will start counting from there. And if we turn it to 20, right now it's in 24-hour mode. If we put it in 12-hour mode, nothing's gonna change because it's 2 a.m. and so the LED showing for PM does not turn on. So for the alarm, we're gonna set the time at 3:02, 1 second. So we'll set the second, set the seconds to 1, save that, reset, set the minutes to 2, save that, reset and set the hours to 3, save that, and then set alarm and make it ring. And when the alarm rings, LED number 15 will light up for a brief period.
As you can see, the LED lit up when the alarm rang. This is our discussion of what we did and why for lab. So we chose to use switches to differentiate between the modes and hours, minutes, and seconds because it was much easier than using the button and resetting, because it would get confusing and we could differentiate which switch was for which mode and to change either hours, minutes, or seconds. And we also chose to use one-hot encoding in our case statement because initially when changing minutes, hours, and seconds, it was getting to be where hour and seconds were changing at the same time, which we didn't want. So we found that using outputting one-hot encoding made it much easier to differentiate between which hours, minutes, or seconds we were changing at a time.
For AM and PM, we decided to just turn on an LED because you can't display an M on the 7-segment display. That's why we decided to turn on an LED instead. And then for setting the time, we chose to use a button because it's a lot easier to count up to the value by just pressing the button a lot of times instead of trying to remember what the binary value of each of that time you want to set is.